Hello, here am I, SeMi, and this is another episode of Pubg Lite Reverse Engineer. Today, we are here to expand our wireshark dissector tool. And to begin with, I would like to explain to those that don't know what that program is. What we are looking at are actually packets sent from client to server and vice versa. So, for example, this is the server packet. Green one is client packet, right? Because we have this port 7777, this is server port, and we see the arrow to the right to our client. As for now, we managed to explore quite few packets. We have them ready as here, I think, for example. Yeah, this is, for example, the NMT welcome packet. This is one of the initialization packets. And we are trying to reverse engineer the replication packets. So, what we have now, as you can see, one packet can have multiple bunches inside it. So, for example, we are taking first bunch, and this bunch have the header and the payload. Inside we have the header. We can see the payload row. It's because it's not dissected here. As you can see, this packet is partial. So this bunch is partial. This one bunch is just 1/2 of the full bunch. So we are copying this value and we are appending it to the next bunch value, as this is partial final. And we can see here actor setup. We can get inside. We can see that this is setup packet of BPST extra player controller class, and this is on the channel 2. Here, channel index 2, because channel type is also 2 for actors. So we can get more inside. We can see serialized location, rotation, scale, velocity, and there are the values. This is not full. The ST extraplayer controller have much more values, but I need to write them all here. And we did that, but another bunch is also partial, but we can't see the payload here. So what we're gonna do now is modify our dissector code, which is written in Lua. And actually I found already the place we need to modify. As you can see here we have the handle setup part, yeah, and here we have condition that if setup is done, then we are at the updating packet. Handle update is, as you can see here, empty. What does that mean? If we get back to these bunches, we have first setup packet, right? It's serialized here, and at this point it's setting the setup down to true. So every next packet goes through this part and ends up here doing nothing. What we know is that we are not sure, but currently if bunch have this or this true, then it's always setup. It's always setup packet then. So we can go and change that condition, that if this or this is true, then it's for sure the setup packet. So what we're gonna do, we can write here is setup variable. We can pass their bunch header, as this values comes from the header, like header here. Oh, sorry. Open the browser. Okay, and here we need to find how keys are named. This is one key. Okay. Or, because or always making if one of these are true, then true. And we are taking the has package map export, right? Right. So is setup, but if it would be true, then it would go to the update. So we need to negate that condition and write and not. Now we can save this code, exit the wireshark, oh, and try again. This is packet 42. Okay, we are going inside this bunch. It's still here, and we are going to this bunch, and we can see we can expand the payload, actor setup, exported net GUIDs, and this one is actually BP Lite PC Survive HUD. The next point here would be to reverse engineer the structure of that and serialize test values here under this one, but we don't have serialization complete yet, and we can already move on to the last packet. So this code, it's quite easy. You can see here it's only Lua, so we can modify it without problems and don't need to compile it. We just need to refresh the wireshark and it's okay. So right now our next step would be to read last batch. Of course, we have it already dissected by variant avoider, but I just noticed that here we don't serialize payload, so we will try to do that now. And I guess I found already where it's called. I think it's here. It's our also by variant avoider tool to browse logs from the debugger with call stacks. And as you can see, we can see a very bit right here, and we can also generate call tree. So we know what was the path to writing specific bits. And why do I think this is it? I think so because here we are writing headers and payloads, writing content block payloads, sending bunch. And here we are having its bunch before, its creation of the header. For sure. And here we have sending bunch. It's also header. And this is serialized at the end. So our code must be here, because there is another bunch and this would be the first thing to serialize as it's go from the bottom to the top. Or at least I think it's going like that. Okay. Oh, The hell? Okay, never mind. We can just... Okay, and we are in write bit, so we need to go one step before. Okay, I don't know why. One click, I think. No. Okay, that's not a problem. Okay, and we are inside send properties for RPC, and that was... yeah, no, never mind. Okay, so this one... send properties for RPC. Okay, we can go inside the engine code. Okay, I don't have project files, but that's also not a very big problem. We can just go and open the folder inside here. Oh, we have it. So we can go back and open it as a project. It would be quite easier. I guess this is the send bit. Maybe I'm wrong. It will take a while. Maybe you can identify some functions in the meantime. Not this one. Okay, fos6. It's iterator, I guess. F for playout. It's here. It's almost the end of the function. Yeah, it's send bit. Okay. Okay, so situation would be kinda easy here, I guess. You can go back into here. And we are not using payload anymore. Read 1 bit send. And what would be here? There is 1. And it should be like this. Okay, what we have next? Numeric property. T property 22 bits. Serialize bytes. One 409 63 B. Okay. What's the first argument of You also have the screenshots of how it should looks like. I just need to find it. Serialize bytes. It can't find it, that's weird. Serialize item. Okay, I guess I should be URA property. We have the unumeric property. Unumeric property. Serialize item. Oh my god. But I guess it should be like read 8 prop handle read p int, maybe not this one, prop handle, and next would be read to numeric property value. Okay, 78 bits. Is that correct or is that not correct? Number of bits. I guess it's not correct. Hex 17, 1 412. Okay. You can copy this. See. Open it one more time and run. 7 0. Oh, it's also 0x. Okay, so this is bit perfect. And my implementation is not bit perfect, I guess. But here num payload bits would say 21 hex. Free. So my best guess, it would be that it's that, like that. It's a numeric property, but what it is serializing? I can't get that. What's that numeric property? I would like to know what this is. FieldNet index. Oh, actually, Warranty Voider has sent me a list of his indexes. So I guess we can try to quickly find it. Sorry, I need a minute to scroll through the screenshots because I'm sure that I will get back in the moment. I think I will find the screenshot and get back to you. Okay, so I'm back and we have our fields list. So this is a packet. This packet still is on the channel index 2. So it's 100 true that this is packet bunch for ST extra player controller. We can get in here. We can see that this is rel index 10 and it's, oh my god, Warranty Voider was was explaining this to me. I don't remember which one I should look at, this or this. I guess I should look at this one. That's my lucky guess. It's FieldNet index 10, num payload bits sent, but pawn would not be this player state, so it's either pawn or a player state. It's numeric. Oh, it might be the pointer. Okay. That would be weird as well. But okay. Let's say it's like that. It is a pointer. I know if it's pawn. Let's say it's pawn. Okay. Here, pawn. Also, I'm not pretty sure about this one. Oh, there's only view object property value 2f. We can check that. 2f. That tombox, player tombox? Or 2f this hit target pawn as extra player character. Okay, I'm not sure either. So I guess I should implement this as well. Like here. No, I guess that should be enough. I think we will not be updating the sector today anymore, but we can actually try to we can try to go with the next packet. We have only log for the server, so we will not try to dissect client packets. But here is another server one. So this is 488. Have a few bunches. Oh, you can see this automatically. Okay, I want the last not ACK one. Okay, this is the last no ACK one. Okay, let's leave that one. And maybe we can try with that one. We will drop that inside. And here, I think we need to find first setup packet 00 packets. This is the, we need to find it. Okay, not here, not here. Not here. Oh fuck. Okay, it's not here, but don't worry, we can find it here. A 600D0. Okay, this is this one. And we need to go down till the next send to. Okay. This is our packet. We can find this here. Oh, no, not this here. We can try to copy again. This one. Copy as value. And put in here. Yeah, it's here. That's nice. And we can save it. Setup packet 01. And now we can load it into the log browser. Okay. As you can see, we reversed many functions to know what's happening here. Ooh. Oh, this is an ACK, okay. So we can go with the call tree for doll. Okay. Write content block, field and header, and send properties for RPC. That would be, I guess, that would be the first. I guess that would be the last one. We want to find the packet bunch in the middle, so it's like the third. One for one. This is the line. 1 for 1. No, it's something not right here. We can first try to find this. Guess it's that. Yeah, it's that. Okay, so it was 0101. I guess it's that. 16. 1169. Okay. And here we have two eight one 123. This is the channel index. Is reverse replication paused, close, and is ACK. 1. Actor updates, number of bits, and there it is serialized. So that one would be serialized earlier, I would say. I would say here. Okay, so I guess it will be starting from here. We can go in here. Yeah, and I'm right. B has rep layout. And next one B is actor. Am I right? Yes, I am right. So here I would guess would be non-payload bits. Serialize int packed. We can verify that really fast. DA93. Okay. We can still move in here. 1407. A4. A62. Serialize int packed. One four 1 5 4DA 96. So yeah, I guess it would be actually the non-payload bits from this class. There's no other option. So read non-payload bits is read pint. It would be 1C. This 222, so something is not right. This is in hex, so I guess 18 in hex, it's 24. And 0x22, 0x22, yes, that's right. Okay. So, this is one payload. This is serialization of other payload. And here nine A 150. So it will be good in 8 bytes. Okay. This is this write, I guess. Int wrapped, serialize bytes, and serialize bits. Okay, so this is free. This will be one payload. So yeah, this and this is called payload. Write and wrapped. It would be in How much bits? That's a good question. I think 8, but yeah, it should be 8. It's 9. There is 1 and it should be 8. Okay then. So we can go here. 1, 4, 1. Five, 4. DB77. Okay. And we have here field net index and max field net index, which is, I don't know how much. Okay, I know, 9A. 8. Okay, so read 8 field net index. Oh, we need to delete payload. Field net index. It's 33. Okay, field net index, and next one is serialize bytes with length 1 and data 12. Oh, it's 1 byte. What? Okay. One 407. 1407. A4A. That would be serialize int pact. Okay. So read pint, and that pint would be from the call tree. We were there. No, it's not this. For 1. 54 db 94. Okay, it's here. Okay, that would be the end of today's video. Thank you very much for watching, and hope to see you soon. Bye bye.